Let's see a few more additional sums based on the concepts of AP. The next sum is the sum of first m terms of an AP is same as the sum of first n terms. Show that the sum of its m plus n terms is 0, and it is given that m minus n is not equal to 0. Why this condition is given, we will understand once we do the sum. First, let's see what is given. The sum of first m terms of an AP. What do you mean by sum of first m terms? Sum is S, m terms is S, m, right? Is equal to same as sum of first n terms, that is Sn. So it is given that Sm is equal to Sn. What are we supposed to prove? The sum of its m plus n terms is 0. Now what is sum of m plus n terms? How do we write it? Sum of m plus n terms is not Sm plus Sn. It is not the sum of m terms and sum of n terms. It is sum of m plus n terms. Meaning, sum of m terms is Sm, sum of n terms is Sn. So sum of m plus n terms will be Sm plus n is equal to 0. So there is a difference between Sm plus Sn and Sm plus n. Sm plus Sn is sum of m terms and n terms. Getting it? This is sum of m plus n terms. That's S m plus n is equal to 0 is what we are supposed to prove. Clear? Let's concentrate on the given. We know the formula. This is the formula that we will be using. The given is Sm. So in Sm, we just need to replace n by m, right? So we get m upon 2 into 2a plus m minus 1 into d. That's Sm is equal to Sn, and Sn is n upon 2 into 2a plus n minus 1 into d, the formula that we already know. So Sm formula, Sn formula, both are equal as given, right? Let's cancel 2 and 2. What remains is this. Now let's open the brackets, but while opening the brackets, remember, open the smaller bracket one and then the bigger bracket. So just concentrate on the bracket inside the bracket, the smaller bracket. Let's open it. What do we get? We get m into 2a plus md minus d is equal to n into 2a plus nd minus d. So first open the smaller bracket, then open the bigger bracket. Now let's open the bigger bracket. M into 2a is 2am. M into md is m square d, and m into d is minus md is equal to 2an plus n square d minus nd. Wrote the formula. Open the small bracket, open the big bracket. This is what we have done so far. Now see the to prove thing. What we are supposed to prove, Sm plus n is equal to 0. So in to prove it is clear, we need 0 in the RHS. Because we need 0 in the RHS, let us shift all the terms to LHS so that we get a 0 in the RHS. Clear? But while you are shifting, remember, AA term should be together, square together, and DD together. Okay? AA together, square together, DD together. Let's do it. 2am minus 2an, AA together, plus m square d minus n square d, square together, minus md plus nd, dd together is equal to 0. From the first two terms, take 2a common. What remains inside the bracket is m minus n. Next two terms, take d common. What remains inside the bracket is m square minus n square. Last two terms, take minus d common, and because you are taking minus d common, the sign will change inside the bracket, so what remains is m minus n is equal to 0. Now you all can see in the first term and in the last term there is m minus n already common. Now just observe the middle term. Can we get m minus n here also? Yes, we can, by using the formula a square minus b square, which is a plus b and into a minus b. So m square minus n square can be written as m plus n, m minus d into m minus n is equal to 0. Now m minus n is present in all the three terms, so let us take m minus n common. When you take m minus n common, What remains inside the bracket is 2a from the first term. From the second term, it's d into m plus n, and from the third term, it is minus d is equal to 0. Now you can take m minus n to the other side. Now this is important. You are able to take m minus n to the other side because m minus n is not equal to 0. That is the reason that condition is given. Because if m minus n was equal to 0, first of all, you couldn't have taken it common out, because taking out common is like dividing, and you cannot divide anything by 0. That's the rule in maths, right? And m minus n is going to the other side, it's going in the denominator because it is not equal to 0. Getting it? That's the reason that condition is given, so that you have that option of taking m minus n common or dividing throughout by m minus n. Right? Let's move on. 0 upon anything is 0, so that m minus n will get deleted. What remains is 2a plus d into m plus n minus d is equal to 0. So 2a plus dm plus dn minus d is equal to 0. Let this be equation number 1. This is what we have. We cannot simplify this further. Now come to show that part. What is Sm plus n? See, understand. Sm is m upon 2, 2a plus m minus 1. So what will be m plus n? Sm plus n will be m plus n upon 2 into 2a plus m plus n minus 1 into d. What we have done is, in the formula of Sn, we have replaced n by m plus n. Right? Now look at the bracket. What is there in the bracket? 2a plus dm plus dn minus d. Right? Opening the brackets. Now if you actually see the first equation is 2a plus dm plus dn minus d is equal to 0. Now look at this, first equation and the bracket. Same, 2a plus dm plus dn minus d. So you can substitute this as 0 and write the reason from 1. So this is equal to 0. So Sm plus n is also equal to 0. Hence proved. Right? The sum of m plus nth term is 0. Simple.